Yeah, problem solving. NPTEL में नहीं कनेक्ट थे।
So today we will be discussing on the biomass properties and excuse me, is this Dave? Can you please mute yourself? So today we will be discussing on the second module, that is biomass. So starting with today's class, as we know that biomass is a renewable source of energy that that is a complex mixture of the carbon, nitrogen, hydrogen, and oxygen. There will be other components as well that will be uh, evaluated by various kinds of analysis like proximate ultimate analysis, and those are detailed characterizations of the biomass, but mainly composed of carbon, nitrogen, hydrogen, oxygen. These are the building block of the biomass. So, biomass energy consumption in practice in India, since we know the ancient time, it is used in the forms of, we know that cow dung cake or firewood or hugs. These kind of things, those are natural biomass based products we use for the uh, household purpose. And this kind of direct use of the biomass in the solid form, that was not actually encouraged over the period because they produce lot of smoke and ash. So, with the help of the advanced technology, there are some various means of the biomass conversion. Those were mostly focusing on biofuels production. Biofuels in the forms of biochar, biodiesel, as well as biogas production. In total, about 95 to 97% of the world's bioenergy production, it is currently being produced by the direct combustion of the biomass. And the perspective of increasing the large-scale combustion of natural biomass and its co-combustion with the semi-biomass or other existing solid fossil fuels like coal, petroleum, coke, this kind of thing seems to be one of the main drivers for biofuel promotions in many countries worldwide in the near future. So, uh, going with biofuel production, so we need to, if we consider it as a biomass as a solid fuel, so we need to first consider the compositions. We need to identify the compositions of the biomass through various characterization. So, the identification and the characterizations of the chemical and phase composition of a given solid fuel is the initial and the most important step during the investigation and further application of those fuels, right? Now, this composition is a unique fundamental code that characterizes and determines the property. Their quality, it highly correlate, these compositions highly correlate with the quality of the fuels and the potential application and environmental issues related to any kind of those solid fuels. So for that purpose, we should have enough idea about its physical, chemical, petrographic, mineralogical, and geographical other studies. We need to we need to perform this kind of studies to get well informations about the solid fuel properties. So there are many examples that I would like to present here. One is the proximate analysis. From the proximate analysis, we mainly um, get to know about the fixed carbon, volatile matter, ash yield, and the moisture. This moisture, whatever be the characterization or the quantity we are getting from the proximate analysis, these whole things like I guess four here the four quantities that we are quantifying from the from the proximate analysis. These are highly important, giving a vital role for the fuel property as well as quality. When we come to the ultimate analysis, it gives you carbon content, oxygen content, hydrogen, sulfur, and nitrogen content. Ash analysis itself an important analysis because when we deal with the fuel in the industry scale as well as transportation process, this ash analysis is very important to do beforehand. So this ash analysis is composed of the silicon, aluminium, iron, and other this kind of minor elements are there. So these trace elements also should be analyzed beforehand. Next is the petrographic analysis, from where we will get the information of organic and inorganic ingredients. Mineralogical analysis, minerals and organic phases. Separation procedures, there will be various kinds of separation procedures like moisture separation procedure, or if you want to separate volatile matter from your fuel source, so those separation process also those defines various fractions out of that. And other analysis of the fuel like low temperature ash or high temperature ash, these are being traditionally done to characterize the specific solid fuels. So when we come to biomass as a solid fuel, it is more or less very simple solid existing fuel like coal and others. So this is biomass is a complex heterogeneous mixture of those organic matter, and to the lesser extent it also has inorganic matter containing various solid and fluid, um, intimately associated with phases and minerals with different origins. Already discussed about the identifications, that what are the characterization we should do before going further conversion of the solid fuel, or before even transportation of the solid fuel or storage of the solid fuel. So we need to also take care, or we need to also have the knowledge about the physiochemical properties of the biomass when we are talking about biomass handling or biomass conversion. So, in this topic, we would like to mention that first point is density. So, in the aspect of the design parameter for handling or storage or transportation, this bulk density or the density of the solid fuel is to be considered. Next point is flowability. So also for the purpose of handling, feeding to the reactor and also the storage facility, for that flowability of the solid fuel that you are introducing to the reactor, that needs to be characterized or that to be quantified. Next point is grindability, because we cannot directly feed the fuel directly to the reactor. We need to do some size reduction or grinding of the fuel before introducing to the reactor. So how much uh, how much your solid fuel is grindable, or how much at what extent we can do the size reduction of your solid fuel that needs to be characterized or that needs to be quantified before. Now the next point is the moisture content. This is very important point. Uh, in context of this moisture content, we are mainly focusing on the how much drying we need to do in the aspect of the storage purpose. So this moisture content itself, it will take lot of energy to dry this biomass, as we are talking biomass. So this biomass as a feedstock, we need lot of energy to reduce the moisture content, because it will ultimately, and if we don't reduce the moisture content, it will ultimately act as a adverse effect on the heating value. Next point is another part of the proximate analysis, that is ash content. So also when we are dealing those fuels into conversion or into heating process in a reactor, that if the ash content is very high, that may come out to be a potential risk of slagging issue and the fouling issue when we are doing such kind of operation like combustion and gasification. Next, next is volatile. Okay. Next is volatile matter. So for this case also, it is playing very important role in the conversion efficiency, because the volatile matter, if it is higher in content, there will be higher fraction of the gas coming out when we will be doing conversion. Such suppose gasification or pyrolysis kind of operation of the biomass, then if the volatile matter content is high, then the gaseous portion will be generated more. Other elemental compositions that we talked about, some trace elements. So for that also, they are also getting they are also playing an important role for the conversion efficiency, and sometimes the compositions also play a role in the thermal efficiency of the whole system. Now we will discuss on biomass classification in a broader sense, that we already discussed a little bit in the first class. So today we will be discussed in a broader sense also its composition, uh, a detailed composition. So much details is not possible to complete in a one class, but there are a lot of research papers are also available. You can refer to those papers where they have analyzed by various characterization the detailed analysis of various biomass for their composition and characterization. So I will be presenting here some of the cases. It is not possible to cover all the cases. So important part of the overview I can present in this today's class. First is biomass, which is a non-fossil fuel, and it is a complex of biogenic, organic, and inorganic solid phases generated by natural as well as anthropogenic or some technogenic processes. Now these processes, it comprises of natural constituents originated from growing land or water-based vegetation by photosynthesis, and it is, or it may be generated by, or it may be sourced by animal or human food digestion, or you can say directly that waste of the waste products from the animal and human daily lives, and technogenic products derived from processing of the above natural constituents. Chemical distinctions among the specified natural and anthropogenic biomass groups and subgroups are significant, and they are related to different biomass sources and origin. Namely, we are talking about plant, animal products, and from their various mixture of plant, animal, or manufactured materials. So when you see this table, this is a general classification. General classification of biomass varieties as a solid fuels, which is resourced by their various biological diversity as well as source and origin. So first is the wood or woody biomass. So where it may be soft or hard kind of stem, branches, bark, chips. So even sawdust, sawmill. So these kind of examples, whatever I am giving, the compositions are not same. When you do the analysis of the bark, when you do the analysis of the stem, those compositions are hugely different. I mean the compositional percentage. I'm talking about contribution. Compositional percentage is highly different. Even the soft wood and the hardwood, this variety I have presented in the further slide. So these kind of segments of the wood and woody biomass, they also have the variety of different different composition. When we are talking about herbaceous and agricultural biomass, so it has some grasses or flowers highly used as a, some of them are used as a energy crops as well as for oil crops, you can say, or these straws and other residues, that is biomass residues, just like husk or seeds, stalks, baggage is highly used in sugarcane industry, that waste product that is highly used in the ethanol production or those kind of alcohol production, breweries production we can use. Aquatic biomass, this is also an important source, like microalgae. So this kind of microalgae as a singular cell, you can say blue, green, or any kind of microalgae. So uh, these are also a source for biofuel production. Animal waste or human biomass waste, bones, chicken litter, or any meals or any kind of, you can also consider the municipal solid waste. Those have the biomass itself. Okay. um, any other sources like industrial biomass, uncontaminated sources, they also have, suppose you can see municipal solid waste and RDF. This is also an important in growing research sources for, as a resources for biofuel production, that is refuse derived fuel. Hospital waste, paper pulp sludge, this is also very huge source for biomass waste as a we can use for the biofuel production. And other biomass mixture, those are blends from above varieties we can have. So these are broad terms of the classification of biomass that we can represent as a solid fuel. So the next one is biomass composition. When we are talking about, so there is variety of biomass and composition varies very significantly. We cannot assure that here the composition of this in even in the same area, if the biomass is different, the composition will be different. So it depends more or less on the environment, on the weather, and also the soil quality. The primary constituents or primary composition of those biomass may be same, but depending upon the environment, the composition may vary on the percentage. So trees, when if you talk about trees, they mainly consist of the cellulose, hemicellulose, and lignin. Those are three primary blocks of the this kind of biomass trees. The chemical composition of the plant biomass varies among species that I already talked about. In general terms, plants are made approximately 25% lignin and 75% of the carbohydrates or sugar. So, see this table. This is primary three blocks, that is cellulose, hemicellulose, and lignin. So I have discussed a little detailed on the three properties, three composition. Cellulose is nothing but a polysaccharide. This comes under this carbohydrate. Okay. So if cellulose is a polysaccharide in which the D glucose is linked uniformly by beta glucosidic bonds, and its molecular formula is C6H12O6 in a N chain. The degree of polymerization that is indicated by N, it is broad and ranging from several thousand to several 10,000. It can go. When we talk about hemicellulose, this is also a polysaccharide which units are 5 carbon monosaccharide, including D xylose and albinose, 6 carbon monosaccharides, including mannose and galactose and glucose. So, lignin, it comes as important source for this tree biomass. It is a compound which constitutes units are uh, various kinds of three-dimensionally structured. Those are universally found in biomass and natural carbon resources of the earth. Okay, so I was talking in the previous slide, that is when we are talking about softwood, hardwood, and suppose I am taking another example of the straw stalks. Okay, so when you see the composition and analysis, you might, if you don't do the composition and analysis, and if you consider all are trees, then it is not, it will not work like that. So when you do the composition and analysis, then you get to know about that the cellulose percentage in the softwood is higher, whereas hardwood the cellulose percentage is higher, as well as the hemicellulose percentage is almost same, almost equal. While we are talking about straw stalks here, the mostly cellulose and hemicellulose predominates. Also, in the softwood, the lignin percentage is higher in among all the cases. So this it varies. Cellulose and lignin percentage, this varies. Continuing to our discussion on the biomass composition, the chemical composition of the biomass, especially when we are talking about ash components, those are highly variable due to extremely high variation of um, okay. First point that I would like to mention, that the bulk chemical composition of the biomass is the first step and common approach for the initial characterization and simplified expressions for the complex system for the phase mineral composition analysis. So when I was discussing this specifically, that ash components are highly variable due to extremely high variation of the moisture, ash yield, and different genetic types of the inorganic matter, those are present in the biomass. In decreasing order of the abundance, the major elements are commonly present: carbon, hydrogen, oxygen, nitrogen, calcium, and potassium. While the minor elements include silicon, magnesium, aluminium, sulfur, iron, potassium, so phosphorus, chlorine, sodium. These kind of minor elements are also present in the biomass composition. So the biomass chemical composition is significantly different from the composition of coal, and the variation among the biomass composition are also found to be greater than for the coal. The compositional variation in the coal that we already discussed a lot from very long time. We have characterized different types of coals and all. But when we talk about the biomass characterization, the compositional variation is very higher in range than the coal. Natural biomass is normally highly enriched uh, highly enriched in magnesium, potassium, calcium, phosphorus. This kind of also oxygen, highly enriched in oxygen, volatile matter, and moisture, slightly enriched in hydrogen. If the hydrogen percentage we can increase anyhow, then it will highly participate or contribute in the biogas production or the gaseous product mixture production out of the biomass feedstock. So the depleted ash, aluminium, carbon, iron, nitrogen, those are comparatively lesser in respect to with respect to coal. When we do the phase analysis of the biomass, we can see the suppose considering the organic matter, we are having solid non-crystalline and solid crystalline. Where in the solid non-crystalline, we are having cellulose, hemicellulose, lignin, and their extractives. Coming to solid crystalline organic matter, those are some oxalate forms of calcium, magnesium, potassium, sodium. These oxalate forms, those having solid crystalline in nature. When we are talking about inorganic matter, the solid crystalline forms are mineral species from phosphate, carbonate, silicate, chloride, sulfate, nitrates, and other mineral classes. Solid semi-crystalline, those are poorly crystalline mineraloids of some silicates and phosphate and hydroxides. When we're talking about solid amorphous, those are amorphous phases. Those are various glasses, silicates. Those are also present in the biomass as a different phase composition. And fluid matter, that we know that liquid, gas, and other fluids. Those are moisture, gas, liquid inclusion associated with the organic and inorganic matters. So now, um, one example I took from a literature. Now, I would like to show that how the proximate, ultimate, and this kind of minor elemental analysis has been done and how it varies with the different biomass sources. So, in this table, you can see that moisture content, it is higher in woody biomass and low and mostly negligible in the animal biomass in comparative to woody biomass. And in between it comes herbaceous and agricultural biomass. But when you are talking about volatile organic matter, then herbaceous or agricultural grasses, it is higher. Obviously, in the animal biomass, the volatile matter is considerably lesser. Fixed carbon. Fixed carbon is higher in the residue. agricultural and herbaceous residues it is higher, whereas contaminated biomass you can consider as a municipal solid waste in the contaminated biomass, those at fixed carbon is lower, considerably lower. Ash percentage, this is dry base percentage, and ash percentage is higher in the animal biomass and lower in the woody and woody biomass. Carbon, oxygen, hydrogen, nitrogen, these are the ultimate analysis or the elemental analysis we do, and we get the result out of that. From there, we are seeing that for the carbon, the higher is animal biomass and lower is for herbaceous agricultural grasses. So from there, you can see a lot of variations. Uh, this kind of chart, it will be helpful for you to choose your suitable biomass for your suitable application. That compatibility you can check with that for your system, if you want to deal with high volatile matter, then you will go for some herbaceous agricultural grasses. But if you don't want to deal with most of the don't want to deal with the lot of ash generated, so you will go for the uh, woody biomass. So it will have lesser ash content. You can also refer there are some oxides compound. So those oxide compounds, based upon that, if according to your requirement, you can select your suitable biomass feed source. The potential of the biomass and biomass products to contain preferably phases with more oxygen containing functional groups like hydroxyl groups or carboxyl groups, ether or ketone groups. Those are highly reactive functionalities. And the chelates, light hydrocarbons, carbohydrates, oxyhydroxides, carbonates, chlorides, and phosphate. Those are the phases of the biomass and biomass products. Also, there are phases like aromaticity, functionality, uh, silicates, and sulfides in comparison to the other solid fuels. The moisture content in the biomass is mineralized in mineralized aqua solution. So when we are talking about the moisture content that we get from the proximate analysis, that moisture content is nothing but the mineralized aqueous solution which contains different kind of cations like aluminum, calcium, iron, magnesium, manganese, this kind of cations and anions as well, and some non-charged species. There is intensive mineral precipitation from a saturated solution due to moisture evaporation after the biomass harvesting and during also the biomass drying. So there is mineral precipitation, and such mineral precipitations are the reason from the enhanced leaching of the calcium, chlorine, potassium, magnesium from the biomass harvested and left it in the storage for prolonged period of time. There will be leaching of these elements from your biomass sources. The ash yield is the inorganic residue that results from the complete combustion or oxidation of the biomass, and it is composed of originally and newly formed inorganic phases which is generated from the inorganic, organic and fluid components in the biomass. The inorganic matter comprises of solid crystalline and semi-crystalline amorphous phases in the biomass The actual mineral matter, which is a part of the inorganic matter, it excludes the inorganic amorphous matter and includes only the mineral and the mineraloids in the biomass. When we are talking about ash, it is a very important parameter for approximating the bulk inorganic matter, because it will come and the ash will come under the inorganic matter. So when we are approximating the bulk inorganic matter, so ash quantity is important. Predominantly, the affinity of the elements and the compounds to be inorganic and organic matter, and the possible contamination of the biomass. These are some important parameters before ash handling. And the volatile matter yield of the biomass commonly includes light hydrocarbons, carbon monoxide, carbon dioxide, hydrogen, moisture, and tars. So, is there any question till now? Then I will move next part, which is energy crops. I will move to the next part. Is there any question till now? Then you can ask. So, before going to energy crops discussion, I would like to brief that how we can compare the biomass with the coal, because we are moving from the fossil fuel concept to the renewable concept. So how we were comparing those two energy sources, and how what are the problems, challenges associated with that. First one, the main point comes that biomass having lower heating value than coal, because coal is a solid fuel with very high energy dense solid fuel, right? So biomass is having lower heating value because of its high moisture content as well as high oxygen content. So when you see the heating value equation, then these two quantity higher in quantity, that will reduce your heating value. Next part, in the comparison, the volatile matter content in biomass around 48 to 86 in a rough. When in contrast, the peat or coal is commonly having 12 to 68 percentage volatile matter. So we can see that biomass having more volatile content than the coal source. wherever the fixed carbon content in the biomass is very less, 1 to 38% only. While in contrast, in the peat and coal, the range remains up to 72%, 20 to 72%, which is higher than the biomass. So these two quantity, we can say that coal is a better source of the energy, but is still we are improving the property of the biomass or making it a sustainable way. Sometimes we are also mixing the two energy sources, biomass and coal energy sources, so that we can replace the coal consumption in the market. The high volatile content, specifically the combustible volatile matter, and the low ignition and combustion temperatures are among the greatest advantage of the biomass when we are talking about the other gaseous product formation for thermal conversion, as those are the criteria for highly reactive nature of the fuel. Table refers, see, this is a comparison of biomass and coal. The volatile matter component is higher in biomass, fixed carbon is higher in coal, moisture content obviously higher in biomass, ash content higher in coal. Whereas this ultimate analysis, the carbon content it refers higher in coal, oxygen obviously higher in biomass, that's why it is giving lower heating value. Hydrogen almost similar. Nitrogen almost trace element. Sulfur also trace element I can consider. Some of the coal sources they are having high sulfur content. So now we'll be discussing on the energy crops discussion. The energy crops are some those are called dedicated crops, just like sugarcane, corn, soybean. Those are cultivated to serve as a feedstock for the biorefineries. Biofuel produced using these crops are termed as first generation biofuels from these energy crops. The other energy crops that can find application in biorefineries, those include sweet potato, cassava, barley, sweet sorghum, this kind of thing. Apart from that, several other oil seeds are there: canola, sunflower, cottonseed, jatropha. Those are also being investigated or taking into account for the production of the biofuels. Biorefineries based on these dedicated energy crops are more developed in comparison to the lignocellulosic biorefineries. It is because energy crops that we are talking about, this kind of energy crops, sweet potato, jatropha, or this kind of oil seeds. So these energy crops are very easy to use, having high energy density and give it a better return on investment. However, they also serve as a food for the human population and also give rise to the food versus fuel debate. So these are very compatible energy crops. Those can also sustain in the market. In the economic value, it gives input into the economic value, as well as it maintains the food chain into the mm, human population. The energy crops such as peri- perennial grasses, sweet grass, alfalfa, those kind of grasses, and short rotational forestry, willow, poplar, eu- eucalyptus. These crops can be grown on poor or degraded soil as well, while improving their high energy yields. When we are talking about the short rotational crops, these are growing trees having shown promises for the biofuel production because they are high yield and wide geographical distribution. They are low cost and less labor consuming comparing to the annual crops, other annual crops. So, in compared to the annual crops, these short rotational crops are giving more value to the food chain as well as your energy source, as an energy source. Popular willow, popular willow, these are abundant in the temperate regions. Eucalyptus, those are abundant in the tropical regions mostly. Jatropha. It is being highly researched and highly effective also as an ideal crop for cheap biodiesel production. To mention that major investment have been done in the facilities to improve the ethanol and biodiesel production from the energy crops to replace the gasoline and diesel consumption in the market. So the next part is types of herbaceous energy crops. Very short description of how we can uh, classify the herbaceous energy crops. Bioenergy crops can be classified into three development stages: first generation, second generation, and third generation. The multiple use of these crops as a feedstock often confuses their classification as a bioenergy crops, but the lignocellulose of the first generation bioenergy crops are considered as the second generation crop. So, first generation crops, the energy conversion technologies have already been established in dealing with first generation, such as sugar crops or sugar cane or sweet sorghum or sweet beet crops, starch crops just like rice, wheat, barley, corn, sweet potato, and oil crops like sunflower, soybean, or rapeseed. These are first generation herbaceous energy crops. The second generation herbaceous and energy crops, those include the process in which to switch the raw material from the biofuel from food to non-food lignocellulosic consisting of the polysaccharide cellulose, hemicellulose lignin. The energy conversion technology are still under development. Those are second generation. And the third generation is future technologies such as genetically modified crops or genetically improved microbes, conversion of the organic matters into hydrogen gas, and the proposed are being proposed as a third generation biofuels. Now we will be discussing on the potential of various kind of waste biomass for their energy production out of that. So we are talking about waste to energy, this transition. We also have seen that municipal solid waste as well as industrial solid waste are being taken to the industry for processing those waste, and the energy can be produced out of that. Similarly, when we take the agricultural waste or the municipal solid waste based on biomass based municipal solid waste, those are also a good source of the energy if it is processed in a proper way. So research are also going into those direction, that how those municipal solid waste can be segregated and can be processed for production of the biofuels out of that. Waste-based biorefineries, they play a very important role in the economy for a developing country. Waste that can be a potential raw material for the biorefinery technology, such as through aerobic or anaerobic fermentation, combustion of those waste product in presence of or in absence of oxygen, just incineration and pyrolysis process, resulting in a pollution-free gasification that we are doing of those, mostly those kind of biomass-based waste. Those are gasified to make liquid and gas products out of that. Biomass waste is generated in huge amount all over the world. If you consider as agricultural waste, just like rice straw or wheat straw, the waste from the sugarcane that sugarcane based industry, the huge amount of the waste is being generated as a sugarcane baggages. And corn stubble, those are you can consider as a biomass waste. Industrial waste as well, those containing biomass. So the energetic value of the post-harvest residues is defined for their standard moisture content, which is in limits between 10% for the straws, those rice straw, wheat straw, this kind of straws, or up to 25% for the corn straw. In the cited cases or in the reported studies, they have shown that the energetic values are 14,000 to 18,000 kilojoule per kg, what is very similar to the wood. This kind of post-harvest residues, though those have energetic value, those are very similar to the wood content. So, referring to this table, you can see the energetic value in the megajoule per kg content. So, the most highest it is giving the soybean. So the soybean straws, those have you can cross check that soybean straw, the soybean seed, those give the higher content of the vegetable oil, as well as those straw, those residue, solid residue, those also give the higher energetic values in a comparative way. And also sunflower has also give good energetic value, as well as in other byproduct, not byproduct, these are the byproduct you can consider. But the main this soybean or sunflower seeds, those are mainly used for the production of the vegetable oil. So when you are considering the biomass, the biofuel and biochemical sources, so here you can see by this figure that biomass, if you are considering molasses, wet biomass, algae or oil seeds plants, cellulosic plants, starch plants, a starch containing plant. So here there are many routes for the production of the various biofuels in gaseous form, solid form, as well as liquid form. So, suppose you are considering the wet biomass, from their fermentation you will produce biogas. Whereas in the microalgae or the oil seed, you can convert those oil content to biodiesel in various processes, suppose transesterification or direct liquefaction process. You can convert those biomass quantities into biodiesel, those oils into biodiesel. Also, when you are talking about this molasses or starch content or the cellulosic content, those are being extracted, hydrolyzed, and fermented to produce the biofuels like ethanol, bioethane, or other thing. When you are doing those biomasses for pyrolysis process, the main product will be solid product, that is biochar. So pyrolysis is being done in the absence of oxygen or very low content of the oxygen. So here in this case we get a mostly solid fuels, that is biochar. Also we get pyrolytic oil, and heat is being evolved for this process. Also, we get the quantity, lesser quantity of the syngas, just like methane and hydrogen. So these are the broad aspects that we are talking about biomass as a feedstock for the production of biofuels and biochemical sources. These biofuels, these are also source of various chemicals we can produce. So when the fuels are being derived from the biological sources, among them lipid materials such as extractive based triglycerides, that is called esters of the fatty acid with glycerol, those are found in plants present in most promising sources of the hydrocarbon rich products that are very resemblance of the petroleum. Those highly lipid content, those can be fermented or those can be transesterificate to produce the biodiesel. Oils have very high energy content, and regardless of the high quantity of the chemically bound oxygen, but these have the very high energy content. Besides the advantage of having heating value similar to the diesel fuels, these natural oils are very low in sulfur and nitrogen. We are talking about mostly the biofuel or the bio chemical sources. So we mostly categorize as oil crops and microalgae, waste biomaterial, this kind of classification, rough classification we can do, right? So when we're talking about the oil crops mainly consider, or it includes the soybean crops, sunflower, canola, rapeseed, peanuts. They play a vital role for producing vegetable oil. Now this vegetable oil has a similar structure of the petroleum hydrocarbon and to the glycerol. So currently, biodiesel is mainly produced from the high-yielding soybean oil, rapeseed oil, castor oil, jatropha oil. The biodiesel is commercially produced from these kind of energy crops. So oil crops with a high oleic acid content have better oxidative stability than the oils that are rich in polyunsaturated fatty acid. So with the selection of the low cost sustainable non-food feedstock, improved production processes to improve the quality and low production cost, while oil crops are already a valuable source for the biofuels, and with it has tremendous potential for the increased utilization for the energy purpose. Now, the agricultural production, it also faces enormous challenges which include a variable climate and extreme weather, low production efficiency and very high cost also it causes. So agricultural way, in the way of agricultural production, it also has these kind of challenges, climate variation and weather variation, or sometimes it is extreme weather that we cannot go with the production of those energy crops, or there may be low production efficiency. So these kind of challenges we also face for maintaining the sustainable process for the oil production from those commercial oil crops. So it is very necessary to use the modern breeding technology or biotechnology method to improve the oil yield of the oil crops. So, at domestication and breeding of the perennial oil crops, those crops are having less nutrient loss compared to the annual crops and having high energy efficiency and increase the soil carbon sequestration as well. So these are very efficient and uh, highly beneficial for the carbon sequestration purpose as well. Carbon sequestration in the form of more agricultural way, not in the form of gas hydrate I'm talking about. Microalgae, when the other source of the biofuel production, that is microalgae. So these are potential source for the renewable energy, and they can be converted into energy such as biofuel oil and gases. This type of algae is a photosynthetic eukaryote characterized by high growth rates. Those have high growth rates and high population densities as well. So through a combination of the proper intensity of the light, proper adequate water environment and carbon fertilization technology, the production of the high density algae, the culture or the production of the high density algae is starting to be achieved in a proper commercial way, and the biodiesel production from the high density algae, also involves the chemical conversion of the algal biomass through the trans-esterification process. Since microalgae, those are in the aqueous environment, so those have higher content. So not all the biomass energy conversion process is suitable for the microalgae, right? So for the microalgae, to treat those microalgae and to convert those microalgae biomass for the biofuel like oil and gas, we need to opt for certain conversion technology. All technologies are not eligible for conversion of these aquatic animal or aquatic microorganisms to convert into biofuels. Liquid fuel or the bio oil via pyrolysis or any thermochemical liquefaction process of the microalgae, we can go with those technologies or those processes to produce the liquid fuel or the bio oil. We'll briefly discuss about the biogas and biodiesel. So when we are talking about the biogas, so biogas, it is being produced by the anaerobic digestion of some organic materials. You can consider uh, energy crops, agricultural waste, food waste, plant residues. Biogas is being produced. Now the concern is what is the primary components of the biogas. The biogas primary components are, first one is methane, which is around 50 to 70% roughly, and rest of the portion is carbon dioxide, that is 30 to 50% roughly. Along with there are some trace gases like hydrogen sulfide, water vapor. So this biogas is being produced by processes like hydrolysis of the biomass, the process like acetogenesis, acidogenesis, genesis, These are some processes that we can apply, or we can go with those processes to produce biogas from the biomass sources. And when we are talking about biodiesel, it is being produced from vegetable oil, and from this vegetable oil, those are further processed vegetable oil, or you can say animal fats, or uh, discarded or recycled cooking oils. So those kind of oil sources are being used. Trans esterificated products are being used for commercial production of the biodiesel. This biogas biodiesel portion will be discussed in the later classes, not today. And when we're talking about bio oil, that vegetable oil production, um, this plant oil, the three parts that I have discussed now, esterification, some you go with the pyrolysis process, and somewhat you can go with the hydro treating process. So here, by the esterification process, you will produce biodiesel. From pyrolysis process, you will produce bio oil, which is also called as pyrolysis oil. And from the hydrotreating process, you will have some alkenes. Those are also known as renewable diesels. So these all can be used for the these combustible uh, products. We can use for the energy source as an energy source. So now we will be discussing on the enhancement, like how we can. We have already discussed that what are the shortcomings of biomass as an energy source. So how we can deal with that? How we can enhance the property of the biomass for the production of the biofuels in a high quality biofuels we can produce. So we need to do lot of treatment for biomass to meet the criteria of the quality of biofuel, right? So for the enhancement of biomass properties, it becomes a critical step. Obviously, it should be taken into account for improving the efficiency, energy density of the fuel, and the economic viability of the bio-based fuels. So, there are some key methods that we can opt for enhancing the biomass property for the biofuel production. The treatment method, we need to go for the pre-treatment. So, first is before conversion, the biomass and chemical properties. So mechanical pretreatment, it occurs by size reduction via grinding or by a milling process to improve the surface area and the ease of conversion. So more will be the surface area, the more will be the ease of converting those biomass sources to the biofuels. Next one is the thermochemical pretreatment process. These processes like torrefaction and pyrolysis, they enhance the energy content and hydrophobicity. Chemical pretreatment processes like acid and alkaline pretreatment, they breaks down the lignin and hemicellulose. Those improve the enzymatic accessibility. Next is the biological pretreatment that we can do. That is the microbial action like fungi, bacteria. It degrades the lignin selectively. So we can use those microbes to selectively degrade the lignin. So we can compose the lignin and we can do the pretreatment process for the biomass to make it suitable for the further conversion steps, to making polysaccharides more accessible or more dissolution can be done easily. Now, next process as a part of the pre-treatment you can consider, that is the densification process. So, in the densification process, biomass is oftenly considered to be a bulk and low energy dense material. So, densification will improve the handling and the transport efficiency. So for that we can do the pelletization or briquetting process. So that will make a pellet out of that or make a briquette out of that your sample, and it becomes in energy increased or bulk density will be increased, and those will enhance the combustion efficiency in the further process. So when you are going to do the hydrothermal carbonization, that also converts the biomass into hydrochar, improving the energy density and hydrophobicity. Next one is modification of the biomass composition. How we can modify by altering the composition of the biomass to make it enhance for suitable for the biofuel production. So genetic modification. For genetic modifications, it includes like energy engineering crops with lower lignin content and higher cellulosic content. Selecting breeding, like developing high yield energy crops with favorable traits. Selective breeding, then we can do nutrient optimization, optimizing the soil condition to produce the biomass with better fuel properties. So soil also plays an important role for making biomass properties suitable for the biofuel production. Next part, if you go with the hydrothermal and thermochemical upgrading process, so the hydrothermal liquefaction process that will convert the wet biomass into biocrude under the moderate temperature and pressure condition. Pyrolysis, it will produce the bio oil, biochar and syngas by heating the biomass in an oxygen free environment. And gasification, that will convert the biomass into syngas, that is hydrogen and carbon monoxide, which can be used further as a synthetic fuel or the power generation. So we can also, by means of thermochemical upgrading, we can also use that biomass to directly to the biofuels. And blending and co-processing, blending includes the co-firing with coal, that I was talking few slides back, that co-firing with coal that will improve the combustion efficiency of the biomass when it is blend, not it is utilized as a single energy source, but if it is blend with the coal, then it will be very highly efficient combustion efficiency in the power plant. But the study should be done before the mixing ratio, and those kind of studies should be done beforehand, before putting into in the existing power plant. And co-processing in the refinery, so bio oil is upgraded in the conventional petroleum refineries to produce the drop-in biofuels. So the next part and the last topic for today's class, that is challenges. Challenges we will discuss related to the biomass handling and biomass conversion process. So as we can see that challenges related to biomass, that storage problem, pre-treatment, consistency, diversity, availability, and constant supply of those biomass. Okay, that's why I was talking more focusing on the short-term rotational energy crops. Also, there are challenges which is related to the process specific, that is enzymatic conversion, energy demand, water demand, also capital investment, competitive with traditional petrochemical refineries, and also huge amount of initial investment. So other than that, when we're talking about storage as a challenges for the biomass handling. So high moisture content of the biomass, that will make it very very no, like not suitable for the thermal conversion process, like thermal conversion process like pyrolysis and gasification. So for reducing the moisture content of the biomass, we are going for the process as a pre-treatment, that is drying. Now for the drying of those bulk amount of the biomass, that will also requires energy. So that will be a challenge for energy demand, right? Now, if you consider next as a low bulk density issue of the biomass, that will make you mm, your problem related to higher storage capacity you need, or higher transportation cost you will be having. So for that case, the solution can be pelletizing, that I already discussed. For pelletizing or making briquette out of that, you will be having a higher density as a high density biomass source. Now coming to the properties, when you are having the hydrophobicity nature of the lignin, or crystalline arrangement of the cellulose, that this kind of difficulties, those will have problem in the dissolution process. So for that they have to be treated with lot of chemical treatment. So those also requires this enzymatic conversion process, those also making a challenge for the process. We are making um, lot of high temperature condition pre-treatment processes we are doing. Also sometimes we are also dealing with high concentration acids to make it suitable for the next step before going for the conversion process. So still biomass conversion in a refinery aspect, it is a challenge. So we need to do the optimization, or we need to focus on the blending with the coal, because coal is still, it is having resources. It is not like it is going to finish within 5 6 years or 5 10 years. It will be persisting, but we need to more focus on the less consumption of the coal. So we can go with the co-firing with the coal process, also co-processing of the refineries that I talked about in the last slide. So this kind of approaches we can go with, so that the biomass challenges we can deal with in a step by step format. So that's all for today's class. Today we have discussed about the second module of our lecture, that is the biomass. So next class I will be discussing on the biorefinery part as the introduction and somewhat detail. So if is there any question from today's class, you can ask. I will wait for some time.
Acha, one question is there. In your last slide, you told that genetic modification of these biomasses, which are generally derived from
Yes.
this lignin and cellulose conductor mode. How it is that means genetically. What does it mean? Genetically modification means what does
Genet-
it mean?
Genetically modification mean we can do the like in the biotechnology application we can do some changes in the some DNA, or this kind of changes we can do the genetically engineered crops production, so that we will have more on the like we can tune the those kind of crops and make it different from the existing crops. That will be more giving value for your high density um, oil production, or high density oil source as a those crop by the genetically engineered application.
Okay, this for biofuel production, whether it is probably it will come under this bio diesel and all, and this which one is which content is more suitable? Whether it is lignin content is more suitable or cellulose content is more suitable?
Sorry, what?
See, biofuel that means biomass to biofuel conversion.
Bio oil, if you are talking about bio oil, say, then the lipid content, if it is more in the biomass source, then it will be more helpful for the bio oil production out of that. And
Acha, I will ask you one specific question because we are facing such a kind of issue. That is why
okay.
I am from Kerala, and we are having a lot of issues with this water weeds, water hyacinth.
Okay.
Okay, water hyacinth means I don't know. Actually, it is an African algae, something like that. It will
Yeah.
call, uh, and it is also called in Terror of Bengal. Also, it is another name is also there. I don't know whether you are aware about it.
Yeah, yeah.
This, this water hyacinth. What is the main problem is actually it is absorbing. That means heavy metals and ammonia from the water, and in certain extent it is purifying the water that it is there, and it is many of the scientific communities are utilizing this for this phyto remediation purpose and all these things. It is there, but unfortunately it is growth rate, as you told earlier, it is growth rate is very
Yes.
high growth rate, and once it is during its tenure of life it is okay, but once it is started to degrading means it will create a lot of problem. Why? Because what are all the these elements or these heavy metals or ammonia, what are all it is absorbed it will be again deposited into water, or it is methane production and all these things will be there. Not a problem. It is creating. So whenever I am going through some research purpose and all, I came to know that its root contains more lignin part, and its stem and leaf contains more cellulose part. Cellulose, so more content of cellulose is in on its stem and leaf. My
Okay.
question is. This how this lignin content will affect the bio oil yield, or how the cellulose or hemicellulose will affect the bio oil yield? That is my question.
So basically, from both two, we can go with the production of bio oil. But if you are talking, if you are, I'm more specific to the ease of the operation. So
Yeah.
lignin is very difficult to like dissociate. Okay,
Okay.
very hard to dissociate in the form of it is having complex structure, chemical structure. So
Okay.
in as like in comparison to that, cellulose will be easy to dissociate. So I already discussed in one of my slides that lignin, as it is having very lower rate of dissociation, so it will be like if you want to discard that from your biomass source, that will be, yeah, easy for you to make it more specific yield of biomass. So my suggestion will be like you will more prefer the cellulosic content more in your biomass, so that the yield of the bio oil or biofuel will be more.
Okay. But the question is again, again, see this this water weeds. Once we are trying to dispose these water weeds, we cannot cut the
Yeah,
root, that lignin part into separate, and
yeah,
we cannot keep it separate, and we cannot make it the other
yeah.
part for our purpose.
So
That is
for
why.
that purpose that I discussed about some pre-treatment process. So we
Acha,
can go with those pre-treatment process to make it easy for the lignin part to degrade at a higher rate. We can increase that rate of dissociation by using some chemical pre-treatment process, so that
okay.
that lignin issue, that both lignin and cellulose can be equally participate in the later stage of the processing.
Okay, right. Unfortunately, I could not able to listen all of your classes. Why? Because that is also problem. One problem I am raising in front of you. Why? Because I already joined yet another course of characterization of polymers, elastomers, and composites
Okay,
for
okay,
soil water. And that live discussion is also parallelly going on this class.
okay, okay.
Understood. Okay, and it
Yeah.
is already started at 5 o'clock and it is ending at 7 o'clock. And your class is starting at 6 o'clock and it is planning to end at 8 o'clock. So it is overlapping is there. So we are facing this kind of issue also. Could you
So
please do something?
yeah, the solution maybe, see, I am whatever I'm doing in my live session, I will be uploading this in my YouTube channel. You can
It
refer
is in
those.
recorded. Recorded.
Huh?
It is in recorded mode, or simply your PPT is only uploading.
Oh, it is whole live session will be recorded and it will be uploaded in the my YouTube channel. The link will be here in the live session. There will be one page, right, in the NPTEL online
Hmm.
website. The live
Understood.
session recording courses is there. You can refer, or I can also post this my YouTube link in the question answers forum in NPTEL website. Or if you
Hmm.
have any question, you can directly comment on that video, or you can also comment in the question answer series in the NPTEL website, that we can discuss over there also.
Acha, 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 okay.
If you
Anyway,
have,
every Saturday you are planning to conduct your live section every Saturday at this particular time only.
yeah, yeah,
Is it?
every Saturday, yeah.
Okay. Okay,
Okay,
then thank you.
okay, thank you so much.